today's video, we are going to be solving right triangles in the algebraic form, meaning that you'll see the sides of a triangle labeled with either variables or numbers or a combination of either or. And we're going to use what we know about solving the sides of a right triangle in doing so. So we know whenever we have a right triangle, we have different parts, different sides that have different names. We have the legs and the hypotenuse, okay? And those are important when we use our, knowing which is which when we use our Pythagorean theorem. So the hypotenuse, remember, is always across the right angle. So in this case, my hypotenuse is 8, all right? So that's going to be my c squared. And the legs are the sides that make up the 90-degree angle. And both of those are x in this case. So remember, my Pythagorean theorem is a squared plus b squared equals c squared. And then I just plug in, okay? X is this leg, x is this leg. So we have x squared plus x squared equals, the 8 is the hypotenuse, so 8 squared. Now, when we combine like terms, be careful, okay? Whenever we have an x squared, there's a 1 out in front. So 1x squared plus 1x squared is 2x squared. 8 squared is 8 times 8, which is 64. Okay, then becomes a two-step exponential equation. So I'm going to divide both sides by 2. And I get x squared is 32. And then give myself some room here to get x by itself. You have to take the square root of both sides. So then you would get x is the square root of 32. And if I wanted to approximate that, it would be, use your calculator, 32, 5.656. So I'm going to say about 5.7. Okay, make a little clearer dot there. All right, so basically we're using the Pythagorean theorem and just plugging in our legs, plugging in our hypotenuse, and then solving just like we would solve exponential equations. All right, let's take a look at another example. Okay, over here. Okay, again, I'm going to identify the hypotenuse, which is 90. So across from the 90-degree angle. So that's 2x squared. So that's my hypotenuse, right? And these two sides are the legs. So a squared plus b squared equals c squared. So x squared plus 9 squared, maybe we should do that in blue, x squared plus 9 squared equals. Now, you got to be careful when you have a term like 2x. So when you square it, you need to put it in parentheses, okay? We got away with before with just without putting the x in parentheses, because when you put the parentheses around the x, it doesn't matter if there's parentheses or not, you're still going to get x squared. But when you have a side like this, you have to put this in parentheses. So it's going to be parentheses 2x and the parentheses squared. Okay, so x squared, can't simplify that. 9 squared is 81. 2x squared, remember 2x squared, maybe I'll do on the side over here. 2x squared is 2x times 2x, which is 4x squared, okay? So this is actually 4x squared, okay? And again, you could also distribute to the 2 to each base to get 4x squared. So you have to be careful. That's why I say you have to put parentheses around the term that represents the side. Okay. Now remember there's a 1x here. Okay. Now if I want to get x by itself, I have to subtract 1x squared from both sides. So I get 81 is 3x squared. Okay, again, get x squared by itself. I gotta divide both sides by 3. Give myself a little bit more room. And 81 divided by 3. 81 divided by 3 is 27. Ooh, look at that. 27 equals x squared. Square root both sides. 27 is not a perfect square, so your x is going to equal the square root of 27, but if they ask you to round it, you're going to approximate it to be square root of 27 is 5.2. So it's about 5.2. Okay. Let's look at one more. Okay. So again, I identify the hypotenuse. Bam. There's the hypotenuse across from the 90-degree angle. These sides are the legs, right? This and this. Okay. 6 squared plus 9 squared. Now remember, again, you need to put them in parentheses. So 6 squared in parentheses plus 9x in parentheses squared equals, even this has to go in parentheses. Six x times 6x is 36x squared. 9x times 9x is 81x squared. Okay, over here, so there's two ways you could do this. One way is to put in a calculator. If you have a calculator that allows you to put parentheses, that's great. Okay, if you want to do this by hand, I'm going to do this on the side over here. Okay. So you would square both the 4 and the square root of 17. So it's actually 4 squared, square root of 117 squared. 4 squared is 16. 117, square root of 117 squared is just 117. And you multiply those together. Yikes, that might be ugly. 16 times 117 is 1872. Now, let me just double check if that was that with the radical. So let's see. So 4 square root of 117 squared. 4, oh, let me put parentheses. 4 square root of 117. And the parentheses, make sure the parentheses are fully around everything. Squared is the same thing. Good. So that's a good way to check our answer. Again, if you have a calculator with parentheses, even better to do this for you. So it was 1872. All right, 36x squared plus 81x squared. So 36 plus 81 is 117. Interesting. 117x squared. Then I'm going to divide both sides by 117. You know what's funny? Because when we did it by hand, we could figure out look at this. 16 times 17 is our answer. And we could double check it, but I know my answer is going to be 16 just by doing the math that I did before. So 1872 divided by 117 is 16. Look at that. Sometimes it pays to do stuff by hand. So you get x squared is 16. Square root both sides, and look at that, it's a perfect square. A nice answer at the very end. So your answer is going to be x is positive 4. Remember, just a positive 4, not the negative 4, since we're talking about the length of a side. Now, if we also wanted to find the length of the side, you would plug these back in, right? So if I wanted to find the length of this side, 9 times 4 is 36. Okay, 6 times 4 is, same thing, take this number, plug it in there, is 24. Okay, so if they're asking for the sides, that's always an option to plug them back in to see the sides and see if they equal. Okay, so basically plugging these into the Pythagorean theorem, and just, again, I want to reiterate the importance of putting parentheses around each side. All right, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.